All right. Welcome to the session. I want to talk to you a little bit about REST APIs and how to make your life easier as a programmer. Because sometimes laziness can be a very good quality for a programmer, but sometimes it's also a struggle for us. So sometimes we lack documentation, for example, and we read our code back years later and we don't know anymore what the purpose is. So the same happens to APIs. So why bother? Well, a cloud is as useful as its APIs. You can put all kinds of stuff into the cloud, but if you have no way of accessing it, then it's pretty useless. So you need a way to access your data in the cloud. And microservices means that there is a trend of shrinking complexity, shrinking services, which means that the amount of code that covers one service decreases, but the amount of services you need in order to fulfill the same task is increasing. And with the increasing amount of APIs, increasing amount of services, you have also an increasing amount of APIs. So if you want to have a proper understanding of what you're dealing with and what you're programming and keep it maintainable, you really need to have a structured way to document your APIs. So I think yesterday Geert-Jan introduced the concept of Wanta, who were attending his session yesterday. So you all know what it means, right? Yeah. So for those of you that were not here, Wanta means write once, never touch again. And that doesn't apply to APIs. So just to be sure. And hard to use APIs will probably never be used. And this especially applies to APIs that you make publicly available. If your API is very hard to use, same applies to libraries. If you write a library with an API that's very hard to use, probably nobody will use it. Because your users are going to invest time to understand what functionality you're offering. And if they fail to understand, or the investment you ask from them to understand your API is too high, because it's not properly documented, they will probably stop at some point and say, well, I'm not going to bother anymore. So, in no specific order, I described 5 steps in order to properly document your APIs or use your APIs. It's describing them, mock, use, implement, and test. So, just a few steps. Describing. Well, there are quite some useful tools out there that make your life really, really easy. And one of them is apiblueprint.org. Who of you already know it? So, at least you learned something today. So I will show you the website. So this is the website apiblueprint.org. And as you see, they introduce the API as a central component in any architecture. So you see all kinds of stuff like services or things that are communicating together, and the thing they have in common, or the interface they talk to, is the API. So one thing they said, APIs should be easy to document, because the easier the documentation is, the more useful it becomes. And also it should be easy, the process of creating your documentation, because developers are lazy, so if it's a real hassle to create your documentation, then they just won't do it. So if you make it beneficial for the programmer to write the documentation of the API, so if you can use it for different purposes as well, that means he has a benefit of properly documenting. So this is the concept of apiblueprint.org. They said, well, we should create an easy message format, an easy format, in order to create your APIs, describe your APIs. So, for example, you have a hello world REST endpoint, very simple one. So you have this syntax to describe it. And as you can see, Who of you are familiar with Markdown? Who of you are familiar with wikis? Probably everybody has seen a wiki at some point. Markdown is a very common used syntax to describe wiki pages or format your wiki pages. So they thought, well, we can use this existing technology to create some rules in order to document your API. So that's basically what they are doing. Here. So we have Markdown. And Markdown has the benefit that it's very commonly used. And commonly used items comes with commonly used tooling. So for example, if you go to NetBeans, there is a Markdown plugin you can download and install into your NetBeans IDE. And you have this very nice Markdown editor. And you can preview it and edit the source if you want. So now we can start documenting the API in the Markdown format. And for an example, I created an API for a game server for keeping track of scores of basketball games. So stick it here. So in this case, I want to retrieve some endpoints, create some endpoints, and describe what a game looks like. So I can just, this is very common text. I can describe what the game looks like, what the attributes are, and then the endpoint. So I want to be able to retrieve a game by its ID. So I create a retrieve game endpoint. I say what kind of response does it give, and then an example message, and this can be JSON. So if I now check the preview, I can see here that I have the games with an example URI, and there is an example message of what it could return. So there are some more benefits to describe it, is that you can reuse it in different media. So you can put it in your project wiki, which I did. So this is the wiki for the same project I was creating, and it's the same file. So I can just clone the wiki repository. I can put my API documentation in this repository, and I can view it on the wiki just as easy. And as you can see, the response message is properly formatted as being code. So I can also generate PDF from it, because sometimes you work for a customer, for example, and they require some deliverables, and usually they want it in some document format. And there are also tools you can use which convert a Markdown file into a PDF. So you can use the same source and create different type of output. Because it's just a simple text file, it's very easy to collaborate, because you put it into a version control system. You can all work on it together and make sure that nothing gets lost, and you keep track of the changes. You can embed it into your issue tracker, like Jira, and make sure that it's evolving. So this is all nice, but there is not yet a real benefit for the developer. This is still just work. So, and there's nothing he really gains from it. Yeah, his boss will be happy that he properly documented his API. So now, some real benefit, and this is mocking. The main purpose of mocking is that when you have an API and you want to program against it, you want to be able to use it, you don't want to be depending on the actual implementation. So, for example, in this case, there are two teams developing this app. One team is programming the backend, and another team is building the actual app. So we have a REST interface in between the front end and the back end, two teams working separately, and one API they have in common. We don't want the app team to be depending on the back-end team. Because every time they require a change, they should go to the other room and say, well, you broke something. Or maybe they want to be able to develop independently. The second thing you want is you want to test the documentation of your API. So you created this nice documentation, and you want to write a test. Does it really perform as well as you expect? So if you are able to generate a mock server from your API description, and you're able to test your mock implementation, you're actually testing the description of your API. So there are many tools connected to apiblueprint.org, and if you go to the website, you can list them all. There's a very long list of tooling that's available. So there's a VI plugin, for example. So if you like to write your documentation in VI, you can do it. And one of the very nice tools is called API Mock. And I will show you an example of what it's doing. So I have here created a project. And it's just an HTML5 project. And I put here a markdown, and it's called Let's Core API. So I can show it in NetBeans as well. Project is Let's Core API. And I have here the site root. And here is my API markdown. So I can now run a mock server. So if I now run a mock server, it will say here that it starts listening on port 3000. So let's see what it's doing. We go to localhost 3000, and here I see my endpoint. So if I now compare this to my API documentation, I documented here that the response from the root should be this JSON. And if I now switch to the browser, I see that it's exactly the same. So if I now type /games, which should retrieve all the games. And here I have a very nice JSON array with some example games, which I specified in my API. So with sorry? Yeah, the question is this the same code as in the file? Yes, it's exactly the same. So if I see here, the first game is called JU18, which is boys under 18, second division A, BVG, this is my club, against Woodspeckers 1. So this is one game. And then I go to my API documentation. I say retrieve all games. Here I have the games collection. It says /games, which is the one I was typing. And here I see the first game. It's exactly the same code. So now you see the real benefit for the developer is that your documentation suddenly, instantly becomes a mock server. It takes only a few seconds, and you can start programming already against it. So if you properly documented your API, you can already start using it. And this is one method. So this is what you can run locally. So if you're on a plane or somewhere without internet, you can already use this and start programming against it. And there are even some nice tools which can generate some code based on the REST API. You can use the same tools, point it to localhost port 3000, and generate pieces of your code. There is a second option, which is an online tool, which is also in the list in API Blueprint, and this is called apiary.io. And in apiary.io, I can upload exactly the same markdown file, like this, and it will generate very clickable and convenient documentation for you. So instead of just a static wiki page, it can do more with it. So if I now go to documentation, you see that the format has changed. So it looks much nicer. But also, it's clickable. So here I have one, list all games, to get me the games collection. And now you will see on the right side, on this side, it will print you some extra information. And now I can also create a request and a response. And I can choose a language. So if I want to try the raw request, I want to check what it looks like. And I get the mock server. I press call the resource. And here I see the resource and the response. Switch to example. I can now also choose Java. And now you see that the code on the right side is displaying some example code you can use to call exactly this endpoint. And as you see, even if you're using Maven, it's saying which dependencies you should add to your project to be able to execute this code. So for every endpoint, it generates some example code which developers can use to call this API. So you can choose Java, but also JavaScript, Node.js. So for any major language, there are some examples. And this is particularly nice if you create a public API, which is to be used by any other developer. Because maybe we are all Java developers, but on the outside, out in the wild, there are also Python developers, JavaScript, and all kinds of developers. And it's very hard work to create example code for any type of language. So this website is able to generate even for Perl some example codes. So you don't even have to know all these languages to be able to generate very nice and clickable documentation. Sorry? The only thing I did was going to the editor, and I copy-pasted my markdown content into the editor. Sorry? Yeah, it's the same. It's the same file as I have here in my project. This is the same markdown file. So I can just copy-paste everything that's in here, and paste it in this side. And then I say save and publish, and then it's there. And then you can make it public as well. So you can choose if it's public or if it's private. Okay. Now use. So why should you use your own API? Well, there is a saying in English that says, eat your own dog food, which means the only proper way to test if your API that makes any sense is to start using it. So even if you're creating a public API that you don't intend to use yourself, you should really use it. Make some client and try to call it and see if it makes sense. So that's what we are going to do now. Let's go here. So I created an example application. First, First, I created just a normal jar project with some interfaces in it. And I put the REST API, REST annotations, I put it on the interface. So here I say, well, this is my game service, and the path should be /games. This is the path. And here I have a getGame method, get games, and I just implement all the steps that I need in my API. And this is just the API, so this should reflect what we have seen before. But there's no implementation yet. So the benefit of this is that I can create a jar, just an independent project, and even switch implementations maybe do some experimentation with technology, and I just keep my APIs at the same place. So secondly, I want to, oh, we were talking about use. I'm switching in the wrong context, sorry. Use. Okay. So I create an example project. Sorry about that. An example project. So I wanted to create an app. And I choose Ionic framework for this, no particular reason. I thought it looked nice. So I created an Ionic project for it. And in the Ionic project, I have a base path, which is calling the API to retrieve the data. So here I call localhost 3000. So now I should be able to check if it's still running. Yes, it's still running. So now I should be able to run the project as well. Here we go. I think it works at least. Yes, it works. So now I see exactly the same content as I have in my REST API. So this is the boys under 18, second division A. Oh, now it's gone. Oh, no, it's full screen. Second division A, woodpeckers against BVG. And this is the same as I have here. The same game, only in a different format. Of course, you want it to be able to look nice. So and now can I click it, and I see some details, which is exactly the same data as in my API. So I can build my entire application without written any Java code or any implementation code. So the entire GUI team can just start developing from the point where you started documenting or finished your API documentation. All right, and obviously the team that's developing the app will have some comments. Say, well, sorry, we think we missed some method in the API documentation. So you can start improving your API, and you don't have to have fight with the implementation teams. And you can create a very nice developing cycle, developing mechanism. So for example, you take 2-week cycles, and every week you release a new version of the API. And that means right after releasing your API version, the design team and the app development team can start implementing this API already, independently from the real implementation on the server. And at the same time, the development team on the server side can develop the API as well. And after 2 weeks, you can merge the things together, and then it should work, because both are implementing and using the same API. So, implementing. This is what I was talking about before. So, this is basically implement your REST endpoint and your API. So this is the server team that's going to work now. And for this I created, the server team created the interface. And the interface game service has the annotations. So you're able to provide an implementation and put it in a web container, and then you're good to go. So, and I wanted to test a little. So I took 2 concepts. One is Whitefly Swarm, and the other one is Spark. Just to test how they would react and how easy they are to use. So this is the Wildfly version. As you can see, NetBeans is recognizing, even if the annotations are in a different project, it still recognizes that you have an endpoint. And then I have the source package, and I have the game service endpoint. This is implementing the game service, and here I'm returning a new game. So with this method, it's very easy to switch implementations without switching the interface. And now you can run the same implementation. All right. Now I think what's the most important part is testing, because you can implement your API, but if you did it wrong and you hand it over to the integration team or start using it in production, things might break, because maybe one team, the implementation team, made some mistakes which makes the real implementation incompatible with the mock server. So the design team and the app development team have been developing based on the specifications, but the other team implemented the specification wrong. And this is something you want to discover as early as possible, because the earlier you discover these mistakes, implementation mistakes, the easier the integration will be at the end of the development cycle. So what do we want? We want to have the same test for the specification as well as for the implementation. So in this section, describe, I told you about, no, this one, I told you about the mock server. So it's very easy, once you have written your specification, your API, it's very easy to run the mock server. So what we want to do is we want to test this mock server. So in order to do this, there are some convenient Java of Node.js tools. And those are Mocha and Chai. And they're all coffee and tea related frameworks. And they provide some very nice tools to test RESTful APIs. So they have a very fluent way of defining what it should look like. So in this case, I want to test the root endpoint, the API, / in this case, and I want to make sure that it returns code 200, so I don't want any internal server errors, and the result should have a property games URL. So now I have this test, and now I can start to run it. And in NetBeans it is as easy as right-click your project and select test. And now, as you can see in the output window here, tested, respond with base URLs, it tested the games, and it tested one specific game. So this was my first test, my second test, and my third test. But this test requires the mock server to be running. And we also want to test this in an automated way. So we want to have the build server testing the API anytime the API has been changed. So in order to do this, we want to automatically start the mock server. So if I switch it off now, and I run my tests, it will fail, because the mock server is not available. I go and run my tests. As you see, the tests are failing. So we don't want this to happen on the continuous integration server. So we want to run the mock server automatically and kill it again once we are done with my testing. So in order to do this, I created a simple shell script. This is test mocked API. So what it's doing, it runs the same script as I use to run my mock server. It's calling API mock with the markdown file, and with the ampersand, I'm forking the shell process. So it starts the mock server and then returns to the process and executes the rest of the script. And then I start to run Mocha to run my test. So I specify the command. I say what kind of report I want, and because we are using Bamboo server, there's a special Bamboo reporter. So I specify the Bamboo reporter, I specify the test file, and where the output should go. And then after I'm done running my test, I kill the process in the background. So if I now go here, I can run test mock API, and then it's done. And then when I go to test, I see Oh. No, it didn't output anything. So if I now go to Bamboo, it's Bamboo, I created the build. So I created the project Let's Core, I created the CI build, and there I have different stages. Oh. So go to my Bamboo. I have the project Let's CI, and here I see all the build changes. So I'm sure that everything is working correctly. And then I say configure plan. And now I have a build Java, and I have a test stage. And here I have the test mock API. So if I click test mock API, you can see here that it's running npm install, so make sure that all the JavaScript modules are loaded, and then it starts testing. But as you can see here, it's not running a shell script. This is an npm command. So how did I do this? There's a very nice way in the package.json to make shortcuts to test to scripts. So here in the script section, I created shortcuts to shell scripts. And now I can just use npm mock API, and what it actually does is run the shell script. So this makes it very nice to integrate it with Bamboo, for example, because I can just run use the npm thing they have in Bamboo. So I create a new task, npm task, and I can just run test mock API, and then I can parse the result. So the tester will create the mock.json, and then I can check if there are any errors in the report. And when the test is succeeding, that means that it's running as expected. And then I have to do the same with my Java implementation. So we did the same with the Java implementation. But now I have to run the same test, the test.js, but on a different endpoint. So I need to be able to switch the endpoint of my test. And in order to do this, it is possible in Node.js to switch configuration. And for this, there is the config. And you can create a config module. And there you can specify what's the default configuration and any other configuration. So for example, for the default configuration, I set the API URL to localhost port 3000. And when I check the Java configuration, you can see that it's running on localhost 8080, which is the default port for a Java web container. So by now, creating a script for Java, tests Java API, by creating an environment variable called node_env and giving it a name, the config module knows which configuration file to use. So that makes it very easy to switch context. You just specify this environment variable, and then you can switch between one configuration and the other. So you can run the exact same test and test different endpoints. And so you can check if both endpoints are implemented according to the same specification. So if your mock API tests are succeeding and your Java API tests are succeeding as well, you are pretty sure that the server development team did a good job. So every time the server team makes a commit, the build server gets activated. It will start to build all the things, test the mock API, test the Java API according to the same test, and if they both succeed, then you're pretty sure that you can integrate it at a later stage. All right. Yeah. And well, this this makes it possible to create very nice build pipelines. So you start with specifying your API. You can do it in Markdown. You can use it to publish it on a wiki. You can use it to create PDF reports to provide to your boss to show what a nice job you did. And at the same point, you can use your API documentation to run a mock server, to program against it, to build tests, to create, to test your API, and test any implementations of this API to see if they are complying to the same specification. And to automate this process and configuring a build server like Bamboo, you're pretty sure that anytime any change has been made in the source code repository, that everything remains consistent, and that at the end you can very easily deploy things in production. Any questions? Yeah. Yes, it's operating on the Markdown. I can show you the script. I always forget commands, and I'm a lazy developer as well, so I create scripts for anything. This is the script I created, and it's calling API mock. And if API mock doesn't exist, it will say you to install it. So in this case, npm install -g API mock. So it's an npm module, and only thing you do is run the API mock command and then specify which Markdown file it should generate. No, Markdown on its own, it's like HTML. So you can put anything in it, whatever you want. So it's just a markup language. But the API blueprint.org says, well, if you specify your API using this very generic syntax, but you are complying to our rules and hierarchy in your document, and if you comply to these rules, like a specification on its own, then all the tools that are built around this specification will be able to do something, parse it. So it's like like a standard you can use. You have a question? Or? No, just stretching. All right. Yeah. Yeah. Well, what we do is if your requirements change during the project, which obviously will happen, you need to be able to handle change. So one of the biggest things you need to do in a project is to be able to handle changes, because you know they will come. Usually in our project, what we do, we have 2-week cycles for development. And then we are all coming together on the first Monday of a cycle and discussing all the change we need to do on the API for this cycle, for example. And then we make sure we document it all together in the Markdown file and then push it into the source repository. And from that point, we have 2 weeks to implement it from the app side as well as from the server side. And at the end of the 2 weeks, we merge everything together and we give a nice demonstration of what we have been doing in the last 2 weeks. So this, and because we're continuously testing, you can also see which APIs are not failing. So you can see the progress of the server team, because more and more of their red crosses become green. The question is if the API blueprint would be able to validate the JSON you put into it. No, the mock is not validating, so any garbage you put in the JSON will be the garbage of your mock as well. But what you can do, if you define a scheme for your API, you can test your mock API. So then you can see if your test messages are complying to the JSON scheme you also developed. So the documentation on its own is not checking any syntax or any scheme from the JSON, but you can use the mock API to test if your JSON messages are actually good. And you can either use XSDs or any other scheme describing method. Yeah. Yeah, the question is, do I create any coupling between Maven and the Node.js project, for example? No, we don't, and we don't really have to, because in Bamboo you can specify different tasks within a phase. So it's very easy to first run the Java stuff, then run the Node.js stuff. And you can all integrate them very easily, and you can choose whether you want to be able to do it in parallel or sequential. So if you want to make sure that first your Java code is working before you start to test your NPM modules, then you can configure it like this. If there's no dependency between the two, you can configure them as being parallel, and then they can execute at the same time, which will speed up your build quite fast. But because it's so flexible in Bamboo, we didn't see any requirement for tying the two together. Because usually the backend developers are using Maven and the front-end developers are using other tools. So. Any more questions? No? Well, thank you all for attending.